Hi everyone. In this class we are going to discuss about concept of wavelength, phase velocity and group velocity. First we are going to discuss about definition of wavelength. Definition of wavelength. So what is the wavelength? Wavelength is defined as the distance in which phase changes of 2 pi radians is affected by a wave traveling along the line. Traveling along the line. And it is denoted by, wavelength is denoted by or represented by symbolically lambda. Wavelength is measured in meters. So therefore, the wavelength lambda is equal to 2 pi by beta. The wavelength lambda is equal to 2 pi by beta. And this is the definition of wavelength. Phase velocity. And what is the phase velocity? Phase velocity is defined as the velocity with which a signal frequency propagates along the line at which a particular frequency. Phase velocity is measured in meters per second and it is denoted by or represented by V suffix p. Phase velocity is represented by V suffix p. The change of 2 pi radians in phase angle represents one complete cycle in time and occurs in a distance of one wavelength. The relationship between phase velocity and the wavelength is given by the wavelength lambda is equal Vp into T. So that is equal, time is the reciprocal of the frequency, the phase velocity Vp into 1 by F. So that is equal, phase velocity Vp is equal F lambda. V suffix P is the phase velocity, F is the frequency and lambda is the wavelength. But wavelength lambda is equal to 2 pi by beta and substitute lambda value here, we get the phase velocity Vp is equal F into 2 pi by beta. Where 2 pi F is equal to omega, angular frequency omega is equal to 2 pi F. Substitute 2 pi F is equal to omega, we get the phase velocity Vp is equal to omega by beta, where F is the frequency, omega is the angular frequency, beta is the phase shift constant, V suffix p is the phase velocity. Velocity of the propagation of wave can never exceed the velocity of the light. Velocity of propagation of the wave can never exceed the velocity of the light. However, in radio frequency lines having air dielectric, the phase velocity approaches the velocity of the light. In free space, the velocity of the light value is 3 into 10 to the power of 8 meters per second. Individual waves propagates with the same phase velocity is proportional to the omega. If beta is not proportional to omega and if the wave components travels with different velocities, the envelope of the wave travels with a velocity known as group velocity. And the group velocity is denoted by symbolically V suffix T. Next, coming to the concept of group velocity. So what is the group velocity? If the transmission line or the transmission media is such that different frequencies travel with different velocities, then the transmission line or medium is said to be dispersive. In that case, signals are propagated with a velocity known as group velocity. At a given frequency, the group velocity is a derivative of the angular frequency. At a given frequency, the group velocity is the derivative of the angular frequency with respect to t. With respect to the phase constant. Once again, at a given frequency, the group velocity is a derivative of the angular frequency with respect to the phase constant. The group velocity is usually less than the phase velocity. The interrelationship between group velocity and the phase velocity can be shown below. So therefore, the group velocity V suffix g is equal d omega by d beta. And omega d omega is the difference between two frequencies, that is omega 2 minus omega 1. Similarly, the phase shift constant beta d beta is the beta 2 minus beta 1, where omega 2 and omega 1 are the two close angular frequencies being transmitted, and beta 1 beta 2 are the corresponding phase constants. Beta 2 and beta 1 are the corresponding phase constant values. The d omega by d beta is measured in center frequencies Z0 into P. We know that where Z0 is the characteristic impedance, P is the propagation constant, Z0 into P is the series impedance R plus J omega L, and P by Z0 is the shunt admittance. Now here see the animation, phase velocity and group velocity. In this animation, frequency dispersion in group of gravity waves on the surface of the deep water. The red dots moves the phase velocity in that waveform, in that animation. Red dots indicates the phase velocities, and the green dots indicates green dots propagates which is the group velocity. In this deep water case, the phase velocity is twice the group velocity.